Okay, this presentation will focus on the file structure and descriptions of the various files that you would have if you downloaded the version 4.0.1 of PRMS from the MOES webpage. And so when you download the zip folder and then unzip it in the location, the directory that you choose, at the first level you'll see that there's three folders: a bin, a dist, and projects. And so the bin folder contains the compiled executable for PRMS. The dist folder is pretty much support files that are needed to run the GUI and some other tools within the PRMS structure. And the projects folder contains the actual applications. And so for this example, the example basins that we have in 4.0.1 are for the Apalachicola Chattahoochee Flint, or the ACF basin, and the Merced basin. So looking at one of the examples for the ACF, you'll see that there's three folders underneath that directory: the control, input and output, and then also there are some batch files for execution of the PRMS model, as well as some supporting software. So zooming into that ACF folder, you see the three directories: the control, input, and output, and then we'll go through these batch scripts that we have for actually executing the model. And so the first one that's just labeled ACF is the batch file that executes PRMS in the command line mode. And then the ACF_GUI will actually open up the GUI so that you can run the model and see the outputs on the screen and adjust which outputs you want to visualize. And one thing I didn't mention is that if you look at the bottom of the page, the actual text inside of this script, you'll see that this depends on the name of your control file. So if you change your control file name, you need to update what's in this file. And the same thing with the ACF_GUI, is that it also depends on what your control file name is and the location of it. The third is the ACF_param tool. And so this is another batch script that opens up the param tool program. And so this is a nice easy way to look at and also edit your parameters for your PRMS model. And this one depends, if you look at the window at the bottom, depends on where your parameter file is and what it's called. So here we have acf.params as in the input directory, and also in the control directory we have the name of the control parname file, which actually will be created when you run the ACF print script. And so before you can execute the model in the GUI mode or running the param tool, if you haven't already run this print command for your model, you'll need to do so. And so this is another batch file, and it creates 4 supporting files in the control directory. And so each of these we'll go through next, but this depends on not only what your executable is called. So you see in the bin we have just PRMS, but also in the control file with the directory what the control folder or file is called. So here in the actual control folder, we have your control file, which is acf.control, and then there's the 4 files that are created with the print command. So there's the mod name, the par name, param, and the var name files. And so this just goes through an example of the actual control file. And so zooming in on a piece of that file, we see that the 4 pound signs designate that we're starting to identify a new control parameter. And so in this one we're looking at the data file, what it's called and where the location is, and so that's data_file is that control parameter. The 1 means that there's one thing that you're looking for. The 4 is the type of information that's contained there, and so for this one it's a type 4 because it's a string of characters. And then we actually put the path and the name of the data file on that last line, and you can either use absolute paths or relative paths. So here, using the /, we're actually using a relative path to get to the input directory to go to the data file, which you could do all the way out from C://, so that it would find it from all the way outside. Looking at these other files that are created, the mod name file is deprecated now. It did contain more information about the actual modules you were using in your application of PRMS, and so that's still created by the print command, but it doesn't really add anything to your information, so you can ignore that one. The par name file actually lists all of the parameters that are used in the configuration of PRMS that you have. So based on which routing method, which ET method, solar radiation methods, it gives you the pertinent parameters and describes them in that file. And so here, just an example parameter. So for HRU area, it tells you what module uses that parameter, a description of what that parameter actually is. Sometimes the names aren't as complete to describe what they are. Then looking at the dimension, how many dimensions it is. So this one is only dimensioned by NHRU, and it says that there's 258 of those, and what type the number is. So it can be a decimal number, and the units are acres, and various ranges and default values. Then if we look at the param file, the print command, actually, if you do have an existing parameter file, it will take that information out of that file and populate this file, but it will also add anything that your application of PRMS uses but may not be in your actual parameter file in the input folder. So if you've left off parameters, or maybe there's parameters that you never change the values of and you just want to use the default values, you can actually look at what those are in this file. So the benefit is, if you have an incomplete parameter file, you could actually take this file and put it in your input folder, rename it, and run the model with that one. And lastly, the var name file. So much like the par name file, this one actually outputs all of the possible variables that you could look at from a PRMS execution based on the choices of modules that you specified. And so here's just an example of the var name. So for soil moisture, the variable is soil underscore moist, what module computes that again, and then the dimensions and the number type, and then a short description to give you a better idea of what that's representing, as well as the units at which it comes out of. Moving over to the input directory. For the ACF application, there are 7 files. The acf.data is the master data file, so this has the date and timestamps that PRMS actually uses as available periods to run, and also includes your observations, which typically we have stream flow data from USGS stream gauges, and then if you're not using gridded products for climate, you may have temperature and precipitation by station. And there's also some other data that could be included in there that you can look in the manual to see what other ancillary data. And here's just an example of the header information. So this is the comment section at the top, and so anything that's behind the slashes is treated as comments. So here we have like temperature station data with lat longs and elevation, and then at the bottom of that, then we see these 4 lines, Tmax, Tmin, precip, and runoff, that actually tell you the number of each of those observations that are included in the file, and then followed by at least 4 pound signs to tell PRMS that the time series will follow, and then it does year, month, day. Hour, minute, seconds are those 3 zeros, and then it does each of those observations, so all 79 Tmaxes, then all 79 Tmins, and so forth all the way across the line. Looking at the acf.params file, so this is what PRMS is using. So this is your parameter file to describe the model, and so there's some header information. This is the example of kind of the top end of the ACF parameter file. So we say what model it is, what version, and then leads off with the dimensions for your basin. So as far as number of rain gauges or temperature gauges, number of HRU stream segments are all defined there. And then you'll see that we get down to where it actually starts with the parameters. And so then we have parameters and then 4 pound signs, and then we start to go through actual parameter values. So that first one is SMIDX EXP, but I'll show a different example of a parameter. So again, the 4 pound signs defines the start of where we're describing a parameter. Then the parameter name follows that. The next one is the number of dimensions. There are some parameters in PRMS that we may have 2 dimensions. They may be by NHRU as well as by N-month. So that would be a 2 in that case, but this one is only by NHRU. And then we say that there's 258 of those, 258 HRUs, and that the value type 2 is a float, and so it's a decimal number. We have some parameters that are a 1, which are integer, and so forth. And then it follows with the 258 parameter values. These other 5 .data files are preprocessed climate by HRU or CBH files. So for this larger basin, we preprocess solar radiation, precipitation, ET, and air temperature. And so each of those are contained here in these files. And so just an example, and you'll see this in other parts of these demonstrations as well. And so we have a comment line, and then you say which actual input it is. So here it's Tmax, and there's 258 HRUs, followed by the pound signs again, and then the time series going across each line. For the output folder, once you've executed the model by running that ACF batch script or run it in the GUI mode, it'll create the model and the PRMS summary and the StatVar file for this application the way it's set up. And so the model out file looks, this setup gives us an indication of kind of an annual water balance, so precipitation, ET storage, observed and simulated runoff. And then the PRMS summary file is set up to give you several basin averaged variables. And so it gives you for your time series in a very convenient CSV format, and also gives you the units for each of those variables. And then the StatVar file in this case is set up to provide 4 basic variables that we tend to look at. So basin CFS is simulated, looking at evapotranspiration, solar radiation, and runoff. And again, you have that header information, so that first 4 is how many variables you're outputting, and then it has a numbered time series with, again, the date stamp, and then going across each line represents what you do down each column. And then there's 3 R scripts that are set up in this release, and so if you have R installed on your machine, then you can run these scripts, and it will take these model output files and generate some plots that will show you the storages and fluxes for your simulation. And with that concludes our initial run through to kind of give you an idea of all the files that are contained and what they each represent and how they're used in a PRMS model execution.